All right, geometry students, the two last things that we're going to talk about before we wrap up and have a test soon. One is the exterior angle theorem and the exterior angle inequality theorem. Remember that the exterior angle theorem says if you have an exterior angle of a triangle, it is the sum of the two remote interior angles, or non-adjacent interior angles. The exterior angle inequality theorem says, well, if 3 is the sum of 1 and 2, then the measure of angle 3 has to be greater than the measure of angle 1, and the measure of angle 3 has to be greater than the measure of angle 2. Anytime you can get an equation that says, if you look here in the yellow, something equals this plus this, then you can say that thing is bigger than either one of those two. Does that make sense? If A is equal to B plus C, then that means A is greater than B or A is greater than C. And that's actually the definition of an inequality. A is bigger than B if there exists some number C such that B plus C equals A. So the definition of inequality allows you to go back and forth between here. We usually go from this to that. Good? The other thing we're going to talk about in this last unit is a way of proving things to be true by not actually proving it directly. So it's called an indirect proof. The way an indirect proof works is you are going to identify whatever you're trying to prove, and there's an assumption that whatever you're trying to prove is false. So that's called the indirect proof assumption. Indirect proof assumption. You assume what you're trying to prove is false, or you assume something is false. It doesn't always have to be what you're trying to prove, but most of the time it is. Then you are going to use reason until you get to a contradiction of something that you know is true or something that's given to be true. And that will be called the indirect proof contradiction. And then because what you have assumed to be true led to a contradiction, your assumption must be false. Therefore, we can say our conclusion is true. So you don't actually prove what you're trying to prove. You just show that if you assume it's false, you get something that contradicts a known fact. Let's look at an example. Taking this proof, the measure of angle 2 does not equal the measure of angle 1. That is given to be true. And we want to prove that if the measure of angle 1 does not equal the measure of angle 2, then we want to prove that L and M are not parallel. So my indirect proof, indirect IP assumption, my indirect proof assumption is that L is parallel to M. So if I assume these are parallel, well then that means the measure of angle 1 is congruent to angle angle 1 is congruent to angle 2, because if parallel, then CA congruent. And if these two angles are congruent, then that means their measures are equal by the definition of congruent angles. Now I have a contradiction. I have said they're not equal, but I just proved that they are equal. I point out the contradiction with the IP contradiction. Because I have reached something that is contradicting a given statement, and givens are true, I know that my assumption is wrong, and so my indirect proof conclusion is that my assumption must be false, therefore L is not parallel to M. Why don't you give this one a try on your own, and then we'll go over the answers. Okay, so let's take a look at this one. Very similar setup. I'm given that two segments are not congruent. I want to prove that angle 1 is then not congruent to angle 2. So I'm going to assume that angle 1 is congruent to 2. So that's the indirect proof assumption. Please use more than the first 3 letters to abbreviate assumption. If 1 is congruent to 2, then that means AC is congruent to AB, because if angles are congruent, then opposite sides are congruent. That leads to the indirect proof contradiction, and then I get the indirect proof conclusion. All right, that's really it for chapter 5. So geometry students, study, study, study. Feels like test on Tuesday. I know that's going to be tough, but here we go. I'll probably give you a quiz Thursday and give those back to you right away so you'll have them to study from. Have a wonderful night. I'm sorry the video's late. Peace.